Consider the function f of x equals x squared plus 6x plus 4 for x greater than or equal to -3. We've got a restricted domain here. Part A, find f of x in the form x plus a squared plus b. So we're completing the square. That means f of x is equal to, now the first step is we halve the coefficient of x, so x plus 3 squared. If we were to expand this, we'd get x squared plus 6x, which is what we want, plus 9. We don't want plus 9, so we take away the 9, and then we have the add 4 from the function. That simplifies down to x plus 3 squared minus 5. Part B, hence find the inverse of f. And actually, this is the way we find the inverse of quadratics. We have to complete the square and go through this process. But to do this, first of all, we're going to start by rewriting it as y equals x plus 3 squared minus 5. Swap x and y. Solve for y. So we're going to add the 5. We're going to square root. We're going to take away the 3. Final step, rewrite this as f inverse of x instead of y equals. I'm going to write it as minus 3 plus the square root of x plus 5, just to make it very clear that the minus 3 is not within the square root. And notice that it's not plus minus the square root here when we did the square rooting part. It's not plus or minus the square root because of this restricted domain. We only want the values bigger than 3. If we took the negative value there, the negative square root, we would have ended up with values less than -3. That's actually vitally important for inverse functions, and we're going to come back and see that later in this skill, why we need to restrict the domain for functions like this.